My name is Lin, ID 6411271, and in today's recording, I will be talking about my final project in Big Data Analytics, Project 3. So we're going to be working with MongoDB and JSON in this project. So first, let's take a look at our MongoDB. So this is our database, and we need to be able to perform Mongo export. And for this, we need our connection string, and this is how we get our connection string from here, as I've demonstrated. And then let's go into our notepad again. So this is the Mongo export command. We type in our connection string here and our password. I'll be changing this later on. And our database name is going to be sample supplies, and collection is going to be sales. We can look at this we can notice by looking at the collection looking at the schema. And output is going to be sample supplies 3.json. And okay, let's run this command in our terminal. So we're in our correct directory. Let's do this. Oh, there's a little error here. All right, okay. Now we're getting our 5,000 records. Okay, perfect. Now if we take a look at this, we now have a new JSON file in here in our directory, which is sample supplies 3. And this is how we get Mongo export done, basically. So next is we're going to be reading JSON, and I will be explaining about the JSON structure and how I basically walked with the JSON structure. So let's take a look at our notebook right now. And okay, so I import, and here I read JSON. It's in the same directory, so I'm going to be reading from MongoDB sample supplies.json. And first off, by looking at the head, we can see that items are stored as an array. And this is actually an array of dictionaries. So if we take a closer look, we can see that here there's like several items nested together in as dictionaries in an array. So first we have laptop, and the laptop has tags, price, quantity, and next we have envelopes and so on. So how we handle this is that we want to explode. So by exploding it, we will have individual records for each item in the array. So if we look at this example here, we have exploded this record into 3 different records containing laptop, envelopes, and printer paper for the same ID. So this is the purpose of exploding. Notice that it's no longer an array, it's just objects. And here it was an array. This is why we have to perform the explode function. That is basically it. But still, we still have to walk a lot with the JSON structure, and we'll go through it here. So first, show top 10 products sales. So first, we need to get the product name from the items dictionary, because the name is stored in the items dictionary. Since the product name is nested in a dictionary, we will be using a function to extract it. We will extract the name from the item dictionaries and access the value from within it. So this is the name and this is the item, and we're basically going to be extracting it. And this is how it's done. So first I did it for product name, and second of all I did it for sales. And in sales I applied this calculate function, which is multiplying quantity and price. And if we take a look at it here, we now have 2 new columns called product names and product sales. And if we take a look, we have successfully extracted the name of the item, laptop, and the sales by looking at the price and quantity, which is in the items dictionary as well. So for laptop, there's price and quantity. So yes, this is how we are going to be extracting our values later on throughout the entire project. So after that, I just group by sales and then look at the top 10, but actually there's just 7. So, and then we get our top products, and then I visualized it, and then we can see that laptop takes the lead. Next, query 2 will show top 3 products sales by store. So we have already calculated sales, so this is going to be pretty straightforward. We have store location as well, so we're going to be grouping by store location product name based on sales, and we rank them, we ascending equal false, and then we get our top 3 products per store, and we want the top 3, so rank has to be less than or equal to 3. And then as we can see over here, we have top 3 products for Austin, Denver, London, New York, San Diego, and Seattle. And when we plot it, we get the same top 3 products by sales per store. And it is pretty interesting because the top 3 products are all backpack, laptops, and pens, and they are all in the same order, with laptop taking the lead, followed by backpack and pens for every store location. Next, show rankings of each store location. So store rankings grouped by store location sales, and then we get our sales and rank, where Denver takes the lead in the sales, and San Diego has the least with just 670,000. So this is it visualized in a bar plot. Next, for query 4, we are going to be showing purchase method by gender in the table. So first, we need to extract the customer's gender. So how we do it is, in the customers, the gender, we need to be getting this, and we'll be extracting it the same way we have done it before, by using a function and then applying the function, and we get our new column called sales df gender. If we look at the columns, we have a new column now called gender, which is going to be M or F. And after that, we are going to be creating a pivot table. I'll be using the dot cross tab, and we'll be looking at sales df gender and sales df purchase method. And after that, at the end, by printing it, we get this. But in the instructions, it only shows online and in-store, so I'll be dropping phone, and this is what we end up with, and then I plot it, and this is the result. So they are actually more in-store purchases than online, which is pretty interesting. And last but not least is the showing monthly total sales. So again, we need to be able to extract the date, because if we take a look at this sale date, and we need to get this dollar date from here. And this is not just it, we have to convert it into date time as well. So here we extract it, and then we apply the to date time to the dollar date, and then we create a new column called sales date, and then we just apply it, the extract date, and we have our new column called sales date now. And if we take a look, we have successfully extracted the sales date. And after that, since we want to look at the year month, we do dt.toPeriod_m. And after that, we just group by year month and sum the sales for each month, rename columns, and then we print it out, and this is our result. And by plotting it, this is what we get as a result. And there's no apparent trend or pattern or anything, but I have looked a bit deeper into it into my article in the later report. But yes, that is it for my project. I did some more exploratory data analysis as well, looking at the unique tags, looking at top products by count, and trying to see some total sales for every 4 months, just to see if there's a seasonal trend. And I have also summarized a full report on the analysis in the end, a summarized version of all together. So yes, this is it for my project. Thank you. And at the end of my recording, I will be removing all the unnecessary comments, and you know what, just cut it out, it's fine.